Hey everyone, welcome back to Smart Architectural Programming, your go-to channel for building smart code from the ground up. Today we're diving deep into one of the most powerful building blocks of Java, the for loop. So, there are two streams that would be watching this video. The first stream is on our channel, so welcome back. And the second stream are people who are following along this video on our Introduction to Java book series, book basically. This is one of the accompanying videos to that book. If you're following along, congratulations, you're pushing ahead towards your future dream of becoming a good programmer. And if you're watching along on our channel, thank you for the patronage. But at the same time, I would recommend picking up a copy of our Introduction to Java book. That would help you tremendously in becoming a professional programmer in Java. So without further ado, let's push forward into Java. And for understanding Java, we need to first break it down to exactly what it is. Like, if we don't know what exactly Java is, how are we going to use it appropriately? So for that, let's start looking into what is a for loop in Java, right? So generally speaking, a for loop is used when we know exactly how many times you want the block of code to repeat. It's concise, clean, and makes your program more efficient. Let's break that down a little bit. What do we mean by a block of code? It's a repeat a block of code by when we know how many times it needs to repeat. It's quite simple there. With the while loop that we covered in the previous video, we need to remember that while loop is more so of a dynamic nature, right? We don't know exactly how much times we want to that block of code to repeat. That's why we go for a while loop, which is unlimited times until a certain condition is broken, right? But the condition is outside of the for loop, while loop. While loop only has the condition. It doesn't have the tools to make that the exit condition true, basically. It's outside of the block of code in the while loop. So in the for loop, if you notice here, you'll notice that we have the entry condition, the counter, the condition, and the exit condition tool in the same line as the for loop, basically in the bracket. So that's what we mean by we know exactly how many times we want this to run. So we have those conditions right in the loop itself. So this loop here prints hello Java 5 times. Why? Because it starts at 0, goes up to 4, and increases by 1 each time. That's how this code works. Right? It's quite simple. Now we need to focus on the anatomy of a for loop, right? So we need to break down the for loop and understand the three main components for a for loop to become more effective in understanding what exactly it is. So here you see we have code here. So as I mentioned, we had three conditions right next to the for bracket here, right? And that tells us why we know exactly how many times we want this code to repeat. So if you look at here, int room, follow the cursor here, equals to 1. That is the initialization for a for loop. This is where we declare and set up our loop variable, which basically helps us reach the exit condition for the loop, right? That's why we have, we know that for loop, we know exactly how many times the for loop would run. Then we have the condition, basically. What is the condition that needs to be true for this to work? And that is, as you follow my cursor on, room less than equals to 5. What does this mean? It means quite simply is that as long as the value of the variable that we set here, again follow my cursor, is less than equal to 5, as long as it's under 6 and it is 5 or less, basically this condition would be true and this loop would work, right? This condition is checked before each iteration. If it's true, the loop continues. If it's false, the loop exits. Then we have room plus plus, which is the increment. This increment is basically what leads to the exit condition ultimately, because it increases the variable outside of the scope of the condition. So this room plus plus is always going to be a factor that helps you exit the code, basically. So that's basically the three important components of a for loop. Remember, if the condition is false, the loop stops immediately. So let's focus on some real world examples and basically understand exactly how for loop works, basically, right? So one of the most important real world examples, I'm going to use the same code that you see here, is imagine you're building a floor plan for a smart home, right? You want to label 5 identical rooms automatically. How would you do that, basically? So if you look at the code here, we've already gone over line 1 and explained it step by step exactly what's happening. We have system.out.println, which is the print statement in Java, right? We have designer room number, right? Plus room number. So every time this loop happens, it would print first 1, right? Once 1 is printed, then increment would increase the value of this variable by 1, which would mean that this variable room equals to 1 will become room equals to 2. Then the condition would again check if room equals to 2 is less than equals to 5. If that is true, so it would execute the code again. It would print 2. Then it go back to room plus plus, increase it by 1, so it variable will become 3 until it reaches 5, and exits basically. So that is why in the floor plan, we have labeled 5 identical rooms, 1, 2, 3, 4, 5, using this code, right? And boom, that's how Java loops let us generate repetitive tasks, just like replicating similar architectural elements in software. So now understand basically what we need to understand are the common mistakes that people make when they start working out with Java. So some of the classic mistakes include infinite loops. Like while loops, there's always a risk of infinite loop. If you forget to increment or write the wrong condition, your loop could run forever. So always pay attention that there must be an exit point for the loop. That's basically rule number 1 for all loops, just like the while loops we discussed before. Secondly, we need to make sure we avoid off by 1 errors. So what are off by 1 errors? Starting at 1 versus 0 can trip you up. Always double check your conditions. So basically, our mathematical system usually works from 1, right? 1, 2, 3, 4, 5, 6. 0 is mostly ignored. But in computer science, we start with everything with 0 indexing, right? 0, 1, 2, 3, 4. So generally speaking, people confuse, they start by 1, they're expecting like, let's say we want to cover 5 rooms, right? We instead started by 0. That would cover 6 rooms, because 5 equals to, it would basically have 6 iterations of that code, right? Including room number 0. So that becomes 6 iterations. So always keep an eye on exactly how you want to use that. If you need to use the variable number to designate something, probably you might need to use 1. But in most cases, make it a rule of thumb to follow computer science's core counting mechanism, which is 0 indexing. Always start from the 0, unless you want to use that variable to actually do something, right? Within the block of code. So with that, let's move on to the next problem, which is wrong direction. If you want to count backwards, just tweak the loop to on the opposite direction. Instead of I equals to 5 in the 0 into the counter, you flip it up to 5. It reduces by 1, 1, 1, 1 until you reach 0 basically, and reverse the condition basically. It's not that difficult. You just need to reverse the values of the loop, the condition, and the increment from plus plus to negative negative. And that's basically how one of the 3 most common mistakes that people make when they're starting using for loops in Java, and that's how you can avoid those mistakes. Another aspect to Java is nested for loops is nested looping, right? So you can never nest for loops. You can nest for loops, not never. You can nest for loops, one inside another. This is useful for grids and tables and matrix-like conditions that you need to do, like drawing rows and columns of windows on a smart building. So this adds dimensions. Nesting is mainly used when you need to deal with basically dimensional elements basically on your screen or on your code basically. So that's how you nest a loop and you nest them according to what you need to do. To sum it up, for loops in Java help you repeat tasks, automate structures, and keep your code clean and efficient, just like smart architectural programming. So if you have any questions, let me know. If you found this helpful, give us a thumbs up, subscribe, and don't forget to check out our Introduction to Java book, available wherever great programming books are sold. So with that, we're going to wrap this up. This has been Smart Architectural Programming, where we build code with structure, style, and see you in our next video. Thank you.